So the question number 61 says E is a subset of R, and we are defining a function on E that is nothing other than the characteristic function. The characteristic function is defined from R to R. We know the characteristic function implies just like, f of x or x equals 1 for all x belongs to E, and for all x belongs to E complement, which means that for all the value of E, the function takes the value 1, and for all value other than E, it takes the value 0. So given it is saying that E, the characteristic function, is continuous if and only if they are given certain options 1, 2, 3, 4. We'll check it one by one. So the first option there is given is A is closed. We'll see if E is closed, the characteristic function is continuous or not, since this is like two-way. So that we have to assume a closed subset of E. To take the case, let's say E be singleton 1. So the function, the characteristic function, looks like f characteristic function equals 1 when x equals 1, and it is 0 when x not equal to 0. If you draw the graph, we can see that at 1 the function takes the value 0, and for all other value the function it takes the value 0. There is a break at 1. From this graph, we can clearly observe the function is not continuous at 1, thus f is not continuous. Thus E is closed does not imply the function is continuous. Thus it is not true. First option is not true. Now to check the second option, it says E is open. For that, we'll take an open subset of R. Say we can take, say, the trivial thing is open 0, open 1. So if we draw the graph similar to that of first option, we can see the function takes the value 1 in open interval 0, 1. At 0, the function is defined to be 0, and at 1 the function is defined 0, and for all other values other than the open interval or other than E, it takes the value 0. Thus from the graph you can see f is not continuous, thus E is open does not imply function is continuous. The second option is also wrong. Now to check the third option says E is both closed and open. Well, you can see E is both closed and open set in R. We know that the only open and closed set in R is R itself, and the empty set also. Thus E can either be R or empty set. Suppose E is R, which means the characteristic function takes the value 0 for all real numbers. The function looks like a constant function f of x equals 1. And if E is empty set, the function takes the value 0 for all x belongs to a real number. In both cases, the function is a constant function, thus it is continuous. Thus if If E is both closed and open set in R, it implies F is continuous. The fourth option says E is neither closed nor open. A common example for such set is Q. Let E be Q. Q is not closed and it is not open. So the function looks like at Q for all rational points, say these are the rational points, it takes the value 1. So the function looks like the one drawn here, and for all the irrational number it takes the value 0. So we can see the function is not continuous. F of x, or the characteristic function of Q, is not continuous. Thus E is neither closed nor open does not imply F, that is the characteristic function, is continuous. Is not continuous, does not imply. So the third option is correct, and to prove the converse part, that is F is continuous, implies E is both closed and open, we can check, we can see that by the negation and by using the steps 1, 2 and 4.